Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing very good. Okay, today we'll talk about again revision of, as promised, we are revising what we are doing. We have completed the chapter of integration. We are revising the integration again. We are solving more questions just to get revision and the practice of the questions of different varieties in integration again. All right. So we have solved a lot of questions in the previous 9 sessions, but again we are coming here to solve more questions today. So I have taken almost I think 8 to 9 questions and we'll solve this in the session today. Okay, so again this is revising, so we will not be doing a lot of concepts. If something is there, I'll try to recall from the questions only. Okay, so I hope you're ready. I hope you've prepared the formula sheet. I'm asking you from the day one only. Keep prepare, prepare your formula sheet by yourself for entire calculus, for entire mathematics whenever you can. Do not do it at one day. Slowly, whenever studying, make it. At the same time, you study for 1 hour. Prepare in that 15 minutes or 10 minutes you can use for making the formula sheet. This will help you, recall things every time. Okay, keep going through the formula sheet over and over again. Okay. So I hope you are ready. I hope you're prepared to revise this chapter now with me. So very good questions I've taken. Simple and difficult mixed variety is there. So we'll solve all the questions. Okay. So let's just take start the session and you take your pen and paper out and we'll solve these questions quickly. Let's see. Coming up first is question number 1, bacha. What is it? It is on trigonometry. It is on trigonometry. So we'll see how this will how this will work out. We are asked to find what? Find the value of, please check, the function what we are getting inside this log divided by the coefficient of the function. Okay, the logarithmic function. So whatever we get for b theta, whatever is the function inside the log, divide that with a. Okay, so we'll see that. All right. So I hope you are ready to solve this question with me. Take a pen and paper out and solve it. Solve the first question. If you can solve this question by yourself, pause the video, solve the question and then cross check the solution with me after this, after you complete your answer. Chaliye, the first one. So integration of cos theta upon 5 plus sin theta cos square theta. Good thing about this question is they have already given cos over here. So when I take sin as my t, my substitution sin as t, it will become what? D theta is already there. D theta cos theta is going to be my dt. Okay, but I don't have sin everywhere. I have what, bacha? I have cos. So I have to make that as sin. But this is 2 cos square. It means what? If it was just 1 minus cos square, I can write this as sin square. But it's going to what? It's 1 minus 2 cos square. So I will have to what? Have another constant 2 times of 1 so that I can take 2 common. So you can see here from 2 cos square I can say that there is a plus 2 missing. But I have a plus 5 over here. So I can split that plus 5 into. I can split that plus 5 into 3 plus 2. So have a look now. So what I'm trying to do over here is my integration I will be cos theta 3 plus 7 sin theta, okay, plus 2 minus 2 cos square theta. This should not be doubt. What I did, I split this 5 as 3 plus 2. I wrote 3 here and this 2 over here. Okay, why I am doing that? To make it sin square. Why sin square? Because I can substitute cos and theta is there in the numerator. I can substitute that for sin, sir. We'll see. Okay. So we'll see this will become cos theta d theta upon 3 plus sin theta. Take here 2 common. So plus 2 common. 1 minus cos square theta is there. Okay. What is 1 minus cos square theta? I can rewrite this as simply sin square theta. So I'm going to erase this and write over here in place of 1 minus cos square theta as simply sin square theta. Simply sin square theta. No problem there. No problem over here. Chaliye. Now the substitution comes. I'll show you the substitution over here. Please check. Take t equals to sin theta. Differentiate, bacha. So dt by d theta equals to what? Cos theta. Okay. Replace it over here. dt equals to cos theta and d theta. Yes. Same thing is present over here in the numerator, cos theta d theta. So I'll write this expression again as, please have a look. My I will become what, bacha? dt upon what? 3 plus, please check, 3 plus 7t plus 2t square. 3 plus 7t plus 2t square. I can make the factors of the denominator. Let me try. Yes, I can make it. So I write it as 1 plus integration of dt 2t square plus 7t plus 3. Multiply the constant term and the coefficient of the quadratic term. I get 6. 6 I can write it as 1 plus 1 into 6 is 6 and 1 plus 6 is 7. So I can write this as the factor using the split the middle term dt as 2t square plus 6t plus t plus 3. How come, sir? 60 into t is 60 square, which is the product of the first and third, and sum is 70. Okay, so no problem whatsoever. Please take it common, bacha. What I'm going to get? I'm going to get what over here? Check 2 t is common, so I get t plus 3 and plus 1 is common, so I get t plus 3 over here again, right? So dt upon what is there? Please check. T plus 3 is common, and how much is this? 2t plus 1 is common. Okay, very good. What I have to do over here? Use the partial fraction to write into two different forms. Okay, two different fractions. So I can write this as, I'm not going to do the integration, just using the partial fraction part. So I can write this fraction as 1 upon 2t plus 3 times t plus 3. It's not 2t plus 3, it's 2t plus 1, right? It's 2t plus 1, bacha, not 3. Forgive me. 2t plus 1 and t plus 3. Yeah. This will be what, bacha? 1 upon 2t plus 1 and b upon t plus 3. b upon t plus 3. Now please check. How will I do it? Multiply this. Take the LCM first. This is not 3. Same mistake again. This is 1. This is 1. So what I'm going to get over here? A times of t plus 1, and what I'm going to get over here? B times of 2t plus 1. Okay. Now if you see here, the denominators are same, so I can compare the numerators. So I get what? I get 1 equals to a times of what, bacha? T plus 1 plus b times of what, bacha? 2t plus 1. Okay. One mistake is there. Is t plus 3. Is t plus 3. Okay. T plus 3 and 2t plus 1. Alright. Now do one thing. I have to find the value of a and b for the partial fraction. So put my t as minus 3. Put t as minus 3. What I'm going to get, please check. This will become, 1 will be unchanged because there is no variable on the left hand side. So a times of what? 0 will be there, bacha. Minus 3 plus 3 will be 0. So 0 is there. Plus b times of what? Minus 6 plus 1. How much is that? Is equals to 1 equals to minus 5. Okay. Minus 5b is there. Minus 5b is there. So what's my b value? Minus 1 by 5. Minus 1 by 5. Okay. Now once this is done, let's look for value what we can put for t again to get rid of the variable b. So I can write t equals to what? Please check. Minus 1 by 2. Minus 1 by 2. If you do that, what are you going to get over here? You get minus 1 by 2 into 2. Minus 1 with plus 1 will become 0 now. So please check. So 1 equals to a times of minus 1 by 2 plus 3 and what is this, bacha? Please tell me. B times of 0. How much is that? Minus 1 by 2 plus 3. 3 is what? 6 by 2. 3 is 6 by 2. Minus 1 by 2 means 5 by 2. So a times of 5 by 2. Okay. How much is this? Plus 0. How much is b then? How much is a then? A is simply 2 by 5. Simply 2 by 5. No problem there. A is simply 2 by 5. Cross multiply 2 by 5. So I have a as 2 by 5, b as minus 1 by 5. No problem over here. I'm going to rewrite this equation as, please check. I can write this integration I as what? A upon, how much was that? How much was that? Please check. I'm writing this thing in this form. A upon 2t plus 1. A upon 2t plus 1 dt plus b upon t plus 3 dt. My a value is what? My a value is 2 by 5. So I'll keep the constant outside. 2 by 5, 1 upon 2t plus 1. Okay. And dt is there. Plus, how much is this? Minus 1 by 5 is there, no? So minus 1 by 5 for b. Integration of what? 1 upon t plus 3 dt. This is simply log. So use the log over here. What I'm going to have? If I integrate this, I'll get log, no? 2 by 5 is there. What is this, bacha? This is going to be log of 2t plus 1 upon 2. Ax is there. Okay, same way. Mass 1 by 5 log of t plus 3. Alright, no problem there. Cancel this 2 and 2. This is gone, sir. Okay, what is this now? I can take 1 by 5 common. What I have left now? Log of 2t plus 1 minus log of t plus 3. Now please check here. What I'm getting? So log of 2t plus 1. So log a minus log b. 2t plus 1 is not visible properly. Okay, let me rewrite this part. Let's not have any confusion, bacha. 2t plus 1 and minus log of t plus 3. Now if you check here, log a minus log b is what? The quotient rule for log. So 1 by 5 log of, what is it? A by b, so 2t plus 1 upon t plus 3. Okay, 1 by 5. Now this is the answer that I have. Now please check. What are they asking us? They're asking us to find b theta by a. So what is my a value? A value is 1. A value is 1 by 5 actually. My a value over here, if you compare, a value is 1 by 5. Okay. What is my b value? What is my b theta value? Simply this, 2t plus 3 upon t plus 3. 2t plus 1. Okay. 2t plus 1, bacha. 2t plus 1 upon t plus 3. Okay. All right. So what are they asking us? They are asking us to find b theta by a. If you do that, what are you going to get? Please check. 2t plus 1 upon t plus 3 divided by what? Divided by 1 by 5. How much is that going to be? 5 times of 2t plus 1 upon t plus 3. What's the t value? T I took it as sin theta, right? So write it here. 5 times of 2 sin theta plus 1 upon sin theta plus 3. Have a look. Option D. I'll show you from the beginning. First look at the last slide, what I did. Okay. After comparing this, okay, there is a constant of integration obviously. Everywhere is the constant of integration, bacha. Okay. After integration, you will have the constant of integration, no? So have a look. So if you compare with the given form, a log e with the power what? B theta. Compare this with what we got over here. You got a as 1 by 5. This is my b theta. B theta by a, they were asking this value for this. Put it here, I got it as 5 times of this. Now look from the very beginning. I hope this is visible. This also, and this as well. Now moving on. So moving on, what we have? Question number 2. X square plus 9 integration with dx x upon x power 4 plus 8d1. Okay. So I have to use substitution over here to solve this question. Let's see what can I substitute. Before that, I have to do some modifications, bacha. Have a look. Please have a look. Okay. Whenever you see this kind of condition, try to divide by the common terms. You say if I divide by x square, I'll get something. Divide everything by x square. So x square plus 9 whole thing divided by x square upon what? X power 4 plus 81 whole thing divided by x square. No problem there because we are doing the same operation on both sides. So no problem over here. Division, sir. Division over here. Okay. I equals to what? Tell me. I equals to 1 plus 9 upon x square. That's my numerator. Okay. What about denominator? It will be what? X square. How much is this? Plus 81 upon x square. Am I right? I can see a square and b square term is there. A square is x, b square is what? 9 by x the whole square. I can do some modifications over here. Please have a look. Some transformation I can perform for the denominator part. 9 upon x square is there in the numerator. I can write this as x the whole square, okay, x the whole square plus 9 by x the whole square, right, 9 by x the whole square plus, please check, 2 times of, what is it, bacha? Not plus, I want this to be minus, right, so this has to be minus over here. I am adding the minus to a b term, okay, I am adding the minus to a b term, so minus 2 times of a is x, what is my b? 9 by x. Please check what is this value. X and x will cancel, so minus 18 is there. So I am adding extra of minus 18, I have to what? Remove that out. So minus 18 plus 18 will remove each other. Dx is there. Have a look. So my I will transform now to this 1 plus 9 upon x square, and this will become what? Please check. X plus 9 by x the whole square. Sorry, not x plus, x minus, because a square b square minus 2ab is there, no? A square b square minus 2ab is there. So it will become x minus 9 by x the whole square. So not plus, x minus 9 by x the whole square with what, bacha? With minus, no, minus is gone, this part is gone, plus 18, with plus 18. Okay, now this is with dx. Please check. I am taking now x minus 9 by x as t. Differentiate it, I will get what? I will get what? I will get this as 1, this is minus 9, okay. It will become what? X power minus 2 upon minus 2, okay, minus 2 upon minus 2, alright. So simply what will become? Please check. 9 upon x is there, right? Oh, no, not plus 2. Okay. Okay, differentiation, no? Yes. I was thinking of integration. Forgive me. I was thinking of integration in my mind. So it's going to become what? Please check. It's going to be simply minus 2 times of what? Minus 1. Okay. With what? With a dx equals to what? Whole thing with dx equals to what? dt. Please have a look. So I was thinking of integration, that's why I was thinking dividing by minus 2, but it's differentiation, right? So it will become what, bacha? 1 minus and will become, this will become plus, and 9 by x square dx equals to dt. No problem there, no problem at all. Okay, chaliye. So this is what? This is my dt value, please check. Numerator will be simply dt. My integration will be what? Have a look. I'll have my integration I equals to what? Simply dt upon what is that? T square plus 18. Am I right? This is going to be t square plus 18, no problem. So I can write this as 3 root 3 the whole square, please check. Dt as 3 root 3 the whole square, or 3 root 2 the whole square, not 3 root 2 the whole square, correct na? 3 square is 9 and root 2 square is 2, so 9 2s are 18, so correct, sir. What is this formula? 1 upon a square plus x square. How much is that? Tan inverse. Okay. So I can write this as, this will become integration of what? This whole thing will become what? 1 upon a, so 3 root 2, 1 upon 3 root 2, and what, bacha? Tan inverse of what? T upon, or ax upon 3 root 2. Correct, na? 1 upon tan inverse of x by a, 1 by a, this is the answer. Okay, have a look. Put the value of, if you want, put the value of t over there. What's the value of t? What's the value of t? T is, please check, x minus 9 by x the whole square. So x minus 9 by x the, okay, not a whole square, just simply this thing, 3 upon root 2. I can write this simply as x square minus 9x. So this will become what? 1 upon 3 root 2 tan inverse of x square minus 9 upon 3 root 2x. Okay, 3 root 2x. This is it. I can take x down. Okay, this is my final answer. Have a look. Okay, have a look. Question number 3. 16 plus log x the whole square plus, okay, upon x. This is very, very simple. Just simply take what? Log x as t, bacha. What is this going to be? 1 by x dx equals to dt. I have 1 by x dx. Please have a look. Okay, what I'm going to get? Integration of root of 16. I don't need this because this will become a little bigger. Have a look. Okay, so 16 what? Plus this is t, so t square. This is dt. How much is going to be? Please check. Simply, sir, integration of a square, how much is that? 4 square plus t square. What's the formula for this? Formula for this is x by t. What is x? So t by 2. What's t, bacha, in this case? Log x. Okay, I'll write it next time, no problem. How much is this? So 16 plus t square, no problem. Same root will come here, plus sine a square. How much is a square? So 16 16 upon 2, then what will come? Sir, log will come, the t will repeat again, so t plus same root, 16 plus t square and plus c will come, okay. Put the value of t now. My final answer is, t is how much? Log x by 2, same thing will remain here, 16 plus log x the whole square plus 16 by 2, which is how much? Simply 8, log of, how much is that? Log x plus 16 plus log x the whole square, okay, whole square plus c. My final answer. This is our final answer, bachcha. This is our final answer. What is this formula? For the particular functions, right? I hope this is visible. Have a look. Moving on. Question number 4. Okay. What we can do about this? E power x I can take as, my t. Very simple. Correct, no? Take e power x t. E power x is t. What's the differentiation? E power x dx equals to simply dt. This will become what? I will become what? Integration will become dt, because e power x dx is there. So dt upon root of, I have just 5, then I have minus 4t, and how much I have? Minus 2t. Okay, now please check. So I have to make perfect square in the denominator to use any of the particular functions. So write it like this, I equals to dt upon, I'll take minus 2 common over here, please check. Minus 2 I'm gonna take common. It will become what? This is 2t square, right? 2t square, no? Yes. Because see, it's e power 2x. E power 2x is what? E power x the whole square. How much is e power x? Simply t, so t square. E power x is t, so t square, okay? So minus 2t square. So if you take 2 common, what are you going to get? You're going to get t square plus 2t. Okay? Now I have this 2t over here. So a square and b square, a square and ab is there. What is missing? What is missing? Plus 1 and minus 1. Plus 1 and minus 1. Now you check here. What am I going to get? That's my extra part. Plus 1 minus 1 to make this whole square. Okay? I am getting this as dt upon root under 5 minus, please check, 2 times of what I am getting? T plus 1 the whole square minus 1. Yes or no? This will become what? T plus 1 the whole square, and the minus 1 will be as it is. Okay? Now have a look. I get what? I equals to dt will be like this. How much I have now? I get this as 5 minus minus 2 with minus 1 is how much? Plus 2, right? So 5 plus 2, and this is the bracket, t plus 1 the whole square. Yes or no? I am multiplying this 2 with over here and over here. So minus 2 with 2 plus 1 is t plus 1 is minus 2 t plus 1 the whole square, and minus 2 with minus 1 is plus 2. Okay? So I get what? 7 by 2. Please check. No, I get just simply 7. 7 by 2 I will get in the next step, I guess. 7 minus 2 t plus 1 the whole square, right? So what I get? Now do one thing. Take this 2 on the side and remove it outside. Okay? Now if I take 2 common, what I'm getting? I'm getting 7 by 2 minus t plus 1 the whole square. This whole thing is under root. Am I right? Okay. Now root 2 I can take outside because it's a constant. So 1 by root 2 is outside. Integration will be there. dt upon what is there, bachcha? Tell me. I have 7 by 2 over here. I can write it as root 7 by 2 the whole square minus t plus 1 the whole square. This whole thing is under root, no? Please check. Please have a look. I have taken this 2 outside. So root 2 is outside. I can write this 7 by 2 as root 7 by root 2 the whole square. It becomes a square minus x square. I write it over here. So my integration I has become what? 1 by root 2 integration from where to where? Dt, there is no limit over here. So this is simply what? 7 by 2 in the root the whole square minus t plus 1 the whole square. Am I right? Yes. Okay. Chaliye. T plus 1 the whole square. Now if you do this, what is going to be? A square minus x square is what? Sine inverse will come. So I don't have 1 by a in this case. Simply what I'll get? This 1 by root 2 will remain as it is. I'll get what? Simply sine inverse of x by a. What is x in this case? T plus 1. So t plus 1 upon root 7 by root 2. Okay, and plus c. Take root 2 in the numerator. What I get? 1 upon root 2 sine inverse of root 2 times of t plus 1 upon root 7 plus c. What is my t? My t value is what, bacha? E power x. So write it there. What I'm getting? My final answer? 1 by root 2 sine inverse of root 2 times of e power x plus 1, okay, the whole thing divided by root 7, okay, plus c. This is my answer. Please have a look. Okay, from the beginning you can see. All right, I hope this is visible. First I did for substitution over here. Then I made perfect square. You got this in the form of a square minus x square. To use what? Sine inverse formula for particular functions. I got this as my result. Simple enough. All right, moving on. Question number 5. Okay, question number 5. All right. So I have to integrate this 1 minus x square in the mod. From where to where? Minus 2 to 3. So I have to check for what? Critical points. Means where the sign is changing for the given function. Please check. So I can show you like this. If I take this 3 intervals over here, okay, 1 second. Just see the interval on this side only, I'll show you. If I take the intervals to be minus 2 to 3 I have, okay. If I break it to minus 2 to minus 1, okay, and I break it to minus 1 to 1, and I break it to what? 1 to what, bacha? 3. Please check. I'll show you the nature over here. Take a number between minus 2 to minus 1. Take minus 1.5. Minus 2 to minus 1. Any number is minus 1.5. Put it in the function over here. It will become what? Minus 1.5 the square. It will be bigger than 1 or not? It will be bigger than 1. So this will be what? This whole thing will become negative. The mod had to open with negative sign. So it will become what? Minus of 1 minus x the whole square. Understand why? Check. Because mod has to make this thing as positive. So mod will open with negative sign to make this positive. Because the bracket inside is what? Negative. Reason being because I've taken x as minus 1.5 squared. If you make this square, you'll get what? 1 minus 1.5 the whole square. This will be a positive number. You'll get 2.25. 1 minus 2.25 is how much? Minus 1.25. For that reason, that is a negative number. This has to open with a minus sign. So mod will open with a minus sign. So what is the function? In this interval, what is the function? Minus 1 times of 1 minus x square. So let me write this integration. First part, minus 2 to minus 1. The function is opening with what? A minus sign. So 1 minus x square will be there, but there is a minus sign outside. Okay. Put the dx. This is my first integration. Second, now you see, from minus 1 to 1. Put a value, put 0 over here. Minus 1 to 1 will have 0 in it. Put 0, you get 1 minus 0. How much is that? Positive of 1. Will remain as it is. 1 minus x square only. Because if you put 0.5 also, no, put 0.5. You'll get what? 0.25. 1 minus 0.25 is what? Again positive. So it will remain positive. So I get this as plus. How much is this? Minus 2 to 1. Not minus 2 to 1, minus 1 to 1, right? Minus 1 to 1. Function will remain as it is, 1 minus x square, again dx, okay? The last part, from where to where? 1 to 3. Put a number 2. Put in place of 2x as 2. I get 1 minus 2 square. How much is that? 1 minus 4. How much is that? Negative. This will become what? Minus of 1 minus x square dx. From where to where, bacha? From 1 to 3. So this is my integration now. This is my I value. Now please check here, okay? How much I'm going to get? For the first one, I'll get x with a minus sign outside, x minus x cube by 3 from where to where? Minus 2 to minus 1. Over here, I get what? Plus sign. So x minus x cube by 3, again with from 1 minus 1 to 1, and the last one, what is the last one? Same thing, but with the minus sign, okay? With the minus sign. How much is that? X cube by 3 from 1 to minus 1. no, 1, 2, 3, forgive me. Okay, just give me 1 second. This is a minus sign. The limit is 1 to 3. Please have a look. Limit is 1 to 3. 1 to 3. Now, if you solve this, okay, please solve this. Solve it, okay, and comment your answer. Final answer. I'll give you the answer. Just you comment anyway. What is the comment? What's the final answer? You have to put this minus 1 in the upper limit, both side. Again with minus 2, you will put for the lower limit 1 and then minus 1 and 3 and 1. Okay, if you do that, you're going to get the answer as C. Answer will be C. Okay, please have a look. What did I do? I got to know the nature of the mod. How is this mod opening? From where to where? In this critical points, minus 2, minus 1, 1, 3. How do you know critical points, sir? Put it equal to 0. No, 1 minus x square. If you put equal to 0, you'll get what? You'll get 1 and minus 1. When is this 0? This is at x equals to 1 and x equals to minus 1. So, apart from the boundaries, which is minus 2 and 3, minus 2 and 3, I have how many critical points? Minus 1 and 1. So, I broke the integration at the critical points. So, minus 2, minus 1, 1 and 3. I got my answer as 28 by 3. Please comment below once you find this answer. This should come. This is your correct answer. C is the correct answer, 28 by 3. Have a look. I hope this is visible. Moving on. Question number 6. Find the value of this. Alright, let's see what we can do, bacha. This simple question, I can take this as t, no? Take this substitution. Tan x equals to t. How much is that going to be? It's going to be sec square x dx equals to dt. So, I have taken revision based upon today's session on partial fractions. So, excuse me. So, there are more questions on partial fractions. I have given one of the question. This you have to solve from your side. Okay, chaliye. Sec square x dx upon dt. I'll give you the answer, but you have to solve from your side. How much this will come as, bacha? This will come as, if you check here, acha, this I already have. This I already have. Let me transform the limits now, because there's a limit over here, 0 to pi by 4. The limit is there. If you check now, what I'm getting, when x is 0, for the lower limit, what's my t? T is again 0 because tan 0 is 0. What is next one? X is pi by 4. When x is pi by 4, bacha, what is t value? It is going to be what? Tan of pi by 4. How much is that? It's simply 1, no? Tan pi by 4 is 1. Okay. 1 second. Tan pi by 4, this is going to be simply 1. It's 1. So, t is 1, x is 0, t is 0, x is pi by 4, t is 1. Okay. So, I can write this function now integration I as, please have a look, 0 to 1, the limit has changed from upper limit is 1, lower limit is 0, 0 to 1. This will be simply dt. How come, sir? Sec squared x dx is dt. Okay. And how much is this going to be? Tell me. 2 plus t and 3 plus t. How will you solve this question? Take the partial fraction. 1 upon 2 plus t and 3 plus t. Write it as a upon 2 plus t plus b upon 3 plus t. Okay. If you do this, how much you are going to get? A times of 3 plus t plus b times of 2 plus t. Okay. How much you are going to get over here? 2 plus t, 3 plus t. If you put this as 0 and compare, so what are you going to do from here? Compare the numerator, because the denominator is same. Compare the numerator. So, t as, if you put t as minus 3, no, you are going to get what? B equals to what? Minus 1, correct, no? Please check. If you want, I can show it over here. If you put t as minus 3, this will be 0, right? This is 1. 1 will remain as it is because there is no variable over here. 1 will remain as it is, no variable over here. 2 minus 3 will be what? Minus 1. So, you get 1 equals to minus b. How much is that? B equals to minus 1. Okay. Same way, find a and then put it in this equation and integrate both the parts. After finding a, put in this part, okay, put this as this condition, same thing over here, and do the integration for both the sides. You will get the answer as B. You will get the answer as B. Have a look, okay. Solve it and comment the answer. Solve and, tell me that you got it right. So, GIR. I got it right, sir, okay. Got it right, sir. Moving on. Question number 7, sir. Question number 7. Again, partial fraction. I think, how will I solve this? Same way, sir. Take this 2x plus 1 upon, I'll show you how to do it, but you have to do it from your side again. This you can do. If you have a doubt in partial fraction, I've done a session in integration only on partial fractions. I think I've solved 8 to 10 questions on partial fractions. You have to solve all of them. If you are not, very familiar, if you're not very comfortable with solving questions on partial fractions, okay. So we just make use of this to, reduce the integration into a simpler form so that the integration becomes very, very simple, okay, and easier to perform. So if I do like this, what I'm going to do, a upon x plus 1 is there, bacha. There are different forms of partial fractions. One of them is this also, where we have 3 different functions as a product, the factors. I get this 3 variable b upon x plus 2, and I get what? C upon x plus 3 plus C upon x plus 3, okay, plus C upon x plus 3. Now what are you going to do? Take the LCM. You will get for A as x plus 2 times of x plus 3, okay, plus B as x plus 1 times of x plus 3 plus C as x plus 1 times of x plus 2. Am I right? Divide this by x plus 1 divided x plus 2 times of x plus 3. No problem there. Now put x equals to minus 1. You will get this as 0, this as 0. Find the value of b from a from here. What's the numerator? What is the numerator over here? 2x plus 1. Denominator is same, bacha. Okay, same. So you can compare the numerator. Put x as minus 1, you get a value. Put x as minus 2, you're going to get b value. Put x as minus 3, you're going to get c value. So find a, b, c value from there. Compare the coefficient with 2x plus 1. Your answer would be what? B. Answer is what, bacha? B. Please solve it from your side, okay? Homework. Solve it. So other questions I've given you the steps. I've just asked you to find the final answer. Over here I want you to solve it completely, okay? No big deal. Very simple. It will become what? Log, no? It will become simple logs. Check here. Once you get the coefficient A, it will be a number. B also be a number. C also be a number. You will get log of x plus 1, log of x plus 2, log of x plus 3. Okay. Now there is a limit 1 to 2. So at the last you can put, what are you going to get? 2 plus 1 will be 2 minus 1 will be what? So 2 plus 1, 3 minus 1. So 2. So like that you will get. Log 2 is there, log 4 is there. So answer would be B. Please have a look. Okay. Alright. Moving on. Question number 8. If f be a positive function, okay, for any positive function f, okay, they have given this. One of the integration is I1 equals to 1, k from limit is given 1 minus k to k x f of x. So function is defined for x times of 1 minus x. Same goes with I2 also. Is defined as 1 minus k to k, limit remains same. Function defined as x times of 1 minus x dx. Okay, they are saying 2k minus 1 is greater than 0. Basically k is greater than 1 by 2. Find the value of I1 to I2, the ratio of the two integrals that they have given. Okay, looks complicated but very, very, very simple question. I have taken this question just because the statement of the question looks complicated, but you will see how simple is the solution. So now if you check here, let me start with I1 first. Okay, if I take I1 over here, from where to where, bacha? 1 minus k to k x times of f of x times of 1 minus. Now we know this property, no? For the limits, we can add the limits. We can replace x by what? Sum of the limits a to b minus x. What's the sum over here? K plus 1 minus k. So replace this x as k plus 1 minus k, k plus 1 minus k minus x. How much I get? I get x as k and k goes out. I have what? 1 minus x left. So I can replace x by 1 minus x in the same limit. Will not have any change in the integration. The limit will remain same, 1 minus k to k. I write x as 1 minus x. I write this as, so check this, x will become what? 1 minus x. Okay. This 1 minus x will become what? Please check. 1 minus x dx. 1 minus x, okay, dx. All right. Chaliye. Okay. Now if you see this, what I'm getting? 1 minus k to k. 1 minus x will remain as it is. What I'm getting inside, please check. So f of 1 minus x. Okay. Now what is this? 1 and 1 will cancel and this will become what? Please have a look. this is 1, right? So I can cancel this 1 and 1. I get what? Plus x. Was minus x with minus will become plus x. Same thing, okay? Now I'm going to multiply this with 1 and x individually. So please check. I'll get I1 as, I'll write I1 again, what I got. 1 minus k2 k. I got it as 1 minus x times of f of 1 minus x with x dx. I'm asking you to multiply this together. Please have a look. Same thing I've written here. 1 minus x, this is not power, multiplied, okay? X dx, okay? Now do one thing, just open this bracket. You're going to get what? 1 minus k 2k. I'm multiplying with 1, so it will remain as it is. So f of 1 minus x times of x, okay, dx. Now I'll multiply this with x. So I'm going to get what, bacha? Minus 1 minus k to k, x times of what? This whole thing, f times of 1 minus x with what? X dx. Now have a look. Have a look. X times of fx of 1 minus x. Check here. X times of, in the same limit, x times of function of x times of 1 minus x. How much is that? I1, sir. X times of function of 1 minus x into x. This will become what? Simply I1. Now check here. F of 1 minus x times of x with the same limit. F of x minus times of 1 over x is simply what? I2. So I can write this as simply, sir, I2. Okay, this is simply I2. What is my condition now? From here, I1 equals to I2 minus I1. What I get? 2I1 equals to I2. I'm looking for what? I1 by I2 equals to 1 by 2. Please check. This I2 will come here, this 2 will go here, so 1 by 2. What is my answer? 1 by 2. Option number C. 1 by 2. Okay? 1 by 2. Have a look. I did nothing. Start from I1 here, and then I did for this property for x, I substituted as a plus b minus x, sum of the limit. In the same limit, if you change it like this, a plus b minus x, the variable will be x to 1 minus x. The limit will remain unchanged. We got this result as 1 minus x times of f of 1 minus x x dx. Alright, moving on. Over here, have a look. Okay, question number 9. Question number 9, last problem of the day. Okay, so what is this, bacha? F of x gx be twice differentiable function, means I can differentiate twice in the interval 0 to 2. Okay, satisfying. Okay, this results. Okay, all this result. They are asking us to find the value of fx minus gx. No problem there. So they what they have given, a derivative of second derivative of f is equal to second derivative of g. Okay, and also they are given first derivative at 1 is 2 for the first function f, and for the second function g, first derivative at 1 is 4. They have also given function value at 2 is 3, function value of g function value at 2 is 9. We'll make use of all the given data, but we have to reach where? We have to reach what? To the fx minus gx. Understand this. From the differentiation, we have to reach the function, means we have to do what? Integration, right? We have to do what? Integration. Have a look. Have a look. So I can write this as, from here, from the first condition, f double derivative of x minus, sorry, equal is given, right? G double derivative of x, they have given this like this. I can take this over here. I get what? F double derivative of x minus g double derivative of x is equals to what? 0. Another way of writing this is what? Derivative of first derivative. How much is that? This is what? Second derivative, no? This means what? I can write this as derivative of the first derivative. Derivative of the first derivative. Yes. Now please check. I have written here first derivative. When can I get a differentiation 0? When this number in the differentiation is constant. It means that f dash of x minus g dash of x is equals to what, bacha? A constant k. I'll repeat. This is given condition. I put this gx double x on the left hand side. Differentiation of what? Second derivative of fx and gx. Difference is 0. It means that first derivative, so derivative of the first derivative will be what? 0. This is simply rewriting this in this form. Derivative of the first derivative is what? Second derivative. Now when I can get differentiation as 0? When the term in the bracket where what we are differentiating has to be a constant. So it means that this f dash of x minus g dash of x is what? Simply k. Yes, k. Chaliye. They are given value, right? F dash at 1 and g dash at 1. So if this is k, it means that if I write the value of 1 and 1, the derivative value at f of the function f and g function at 1, it will be the same value as k because the k is independent of the variable x. So I can write here as f dash of 1 minus, okay, f dash of 1 minus g dash of 1 equals to what, bacha? K. How much is that in that case? It's going to be 2 minus 4. How much is that? K. How much is then k equals to? K equals to minus 2. K equals to minus 2. Any problem there? No problem, sir. 2 minus 4. 2 minus 4 is minus 2. Okay. Now we got k. Write the same thing again over here. So f dash of x minus g dash of x equals to what? Minus 2. No problem. No problem. Now integrate again. If you integrate this part again, what are you going to get? Please tell me. This whole thing with what? I'll give a little bit more space. I'll write this thing again. So I'm getting what? I'm getting f dash of x minus g dash of x equals to minus 2. I'm asking you to integrate this with what? With the dx, and this also with the dx. What are you going to get? Please tell me. You're going to get over here as simply f of x minus g of x, okay, and over here what are you going to get? Please tell me. You're going to get minus 2 times of x plus the constant, let's say c, the constant c, okay. Now check here, I have fx value given for something. f2 is 3 and g2 is 9. So put it here. In this function, I'll write it over here. I got my f of x minus g of x equals to minus 2x plus c. They have given f of 2, g of 2 equals to what? Minus 2 times of 2 plus c. What is f of 2 minus g of 2? Please check here. F of 2 is 3 and g of 2 is 9. So right here 3 minus 9 equals to what, bacha? Minus 4 plus c. Okay. How much is this? Minus 6. And how much is that? Plus 4 equals to c. How much I get c value? My constant is what? Minus 4. So I can write my function fx minus gx. Fx minus gx equals to simply what? Minus 2x plus, how much is this? Okay, one mistake. This is not minus 4, this is minus 2, bacha. Minus 2, because minus 6 plus 4 is what? Minus 2. Okay, so it's going to be what? Minus 2. No problem there. Please have a look. C value I got it as minus 2. I am putting it in this equation. I get it as f of x minus g of x equals to minus 2x minus 2. How much am I going to get? They are asking us for what value? For x equals to 4. X equals to 4. So f of 4 minus g of 4 equals to what? Minus 2 times of 4 and minus 2. How much is that? Minus 8 minus 2. How much is that? Minus 10. Have a look. Good question, no? Okay. I hope this is visible. Check the last page first. Okay. I got the fx and gx in minus 2x plus c. Put the value from the given conditions of f2 and g2 to get c as minus 2. Put it back in the function of fx minus gx and got this result for 4 equals to, x equals to 4 equals to minus 10. See from the first page. I hope this is visible. Yes? Alright. So this completes our revision part 2. Alright. So I hope you understood a lot of things over here. I hope I was able to divide this. Partial fraction was there, some other questions also was there. So I hope we have solved all the 9 questions and you have understood all the 9 questions. I've given some homeworks. Please solve those questions and comment in the comment section and let me know what is your view on that. Any other feedback, please make sure that you comment in the comment section and let me know. Be interacting with me whenever you can. I am working hard to come with this video. I want some input from your side also. Alright, with this I would like to conclude the session. Keep working hard, keep positivity around you. See you in the next session. Thank you.